The future of work is automated. Welcome to Aivora.
Here's the thing about corners in video games. In 2007, Crytek blew everyone away with its realistic lighting. But look closely at where two walls meet. The shadow is wrong. Corners don't look like that. But here's the thing. The technique behind that lighting, screen space ambient occlusion, has a hidden flaw. It can't actually handle real corners. Instead, it creates a dark halo that doesn't exist in reality. Which means this video is about a single presentation from 2012. Jorge Jimenez stood on stage at SIGGRAPH and showed us exactly why corners don't look like that. And the fix changed everything. Before SSAO, ambient occlusion was ray-traced or pre-baked into textures. It looked perfect but couldn't run in real time. Games needed a hack that was fast, not accurate. In 2007, Crytek introduced SSAO for Crysis. The idea was simple: sample the depth buffer around each pixel and count how many samples are behind geometry. Fast. Cheap. But fundamentally broken. Here's how it works. For every pixel, you take random points in a hemisphere around it. If those points land behind the scene geometry, you assume occlusion. It's an approximation. And approximations have flaws. The flaw appears at corners. SSAO sees a depth discontinuity, one wall far, one near, and assumes occlusion. But a real corner has geometry that casts shadow correctly. SSAO creates a dark blob where there should be a gradient. That's exactly what Jorge Jimenez showed in 2012. His talk was titled "Corners Don't Look Like That, A Practical Guide to Screen Space Ambient Occlusion." He dissected every failure mode. The room went silent. Let me show you the comparison. On the left, ground truth from a ray-traced render. On the right, SSAO. The corner in SSAO is too dark, uniform, and lacks directional detail. It's an amateur painter's shadow. The root cause is simple: screen space only sees what's visible. It doesn't know about geometry behind the camera or behind foreground objects. True occlusion needs world information SSAO can't access. Other artifacts include light leaking, flat surfaces get false occlusion because of faraway geometry. And edges get dark halos that make objects look dirty. Players noticed. Critics complained. If this surprised you, hit like so YouTube shows this hidden history to more people. Because the fix Jimenez proposed is even more interesting. Drop a like now and I'll show you the solution. The solution wasn't to abandon screen space, it was to add direction. Jimenez and others proposed directional occlusion. Instead of counting occluded samples, measure from which direction the light is blocked. Bent normals store that direction. NVIDIA's HBAO, horizon-based ambient occlusion, built on that idea. It traces horizon angles in the depth buffer to determine occlusion. Corners finally looked like corners. The halo disappeared. Today, we have ray-traced ambient occlusion in games like Metro Exodus Enhanced Edition. It's the ground truth that SSAO wanted to be. But even modern games still use SSAO as a fallback. The legacy lives on. What the 2012 talk taught us is that every graphics hack has a hidden cost. SSAO was a brilliant shortcut, but it lied about corners. Knowing the lie lets you fix it, or use it intentionally. The truth is, if you're building a game today, you can still use SSAO, but you must understand its failure modes. Use directional variants. Combine with denoisers. And never, ever trust a corner. If you're building games or just love graphics tech, hit subscribe. I break down these hidden details every week: the tricks, the failures, the fixes. Subscribe now so you don't miss the next deep dive. Next up, why skin in games looks waxy. The secret lies in subsurface scattering, a 2001 paper by Hanrahan and Kruger. I'll show you how game developers cheated for years and how ray tracing finally fixed it. Subscribe so you don't miss it. Next week we look at the subsurface scattering problem, why old games looked like plastic and how a 2001 paper changed everything. See you then.